Okay, so what is a matrix? And the answer is very simple. It is a matrix is a rectangular arrangement of numbers. And quite literally, that is all that a matrix is that when you organize numbers in a fixed order, that's a matrix. So if I have A, which is equal to 3, 5, 7, 9, this is a matrix. If I have B equals to 2, 6, 7, 8, minus 2, 0, this is a matrix. Basically, I'm taking numbers, I'm arranging them in a rectangular form. And square is rectangle. What is important is something known as dimensions of a matrix. The way of finding that is that a dimension of any matrix is basically the number of rows times number of columns. So if we move to matrix A, how many rows does it have? It has 2 rows. How many columns does it have? It has 2 columns. So this is a 2 by 2 matrix. Let's look at B. How many rows does B have? It has 1 row, 2 row. How many columns does B have? 1 column, 2 column, 3 column. So this is a 2 by 3 column, 2 by 3 matrix. And that's really it. You can create matrix of any dimension, any RNC. So that's what a matrix is. So obviously the next question is, why do we need matrices? What's the use of matrices? Before that, let's take a look at some matrix operations. So we're going to look at matrix addition and subtraction. We're going to look at something called scalar multiplication. And we are going to look at matrix multiplication. Okay, so let's start with matrix addition and subtraction. So addition, subtraction. So I'm going to write down 2 matrices. A is just any number, 3, 7, 2, 9. And suppose B is 6, 9, 4, 3. We want to add these 2 matrices. So suppose we want A plus B. This is very straightforward. All we have to do is add the individual elements. So 3 plus 6, 7 plus 9, 2 plus 4, and 9 plus 3. So what we get is 9, 16, 6, and 12. This is A plus B. Okay, so the only reason we were able to do this is because both A and B are 2 by 2 matrices. 2 rows and 2 columns, 2 rows and 2 columns, and as a result, after we've added them, we also have a 2 rows by 2 columns, a 2 by 2 matrix. Subtraction, exactly same thing. A minus B gives us what? 3 minus 6, 7 minus 9, 2 minus 4, 9 minus 3. So we have minus 3, minus 2, minus 2, and 6. This is A minus B. And see, once again, this is a 2 by 2 matrix. Now, if we have a matrix C, which is suppose 3, 7, 2, what is the dimension of this matrix? There are 3 rows and 2 columns. So this is a 3 by 2 matrix. Now, if we try to add A plus C, this does not exist. We cannot add A and C. We cannot subtract A and C or B and C. So what we see is that matrix addition or subtraction is only possible if the 2 matrices that we're dealing with have the same dimension. Have the same dimension. Otherwise, matrix addition or subtraction is not possible. Next, we're going to take a look at scalar multiplication. So scalar, the word scalar is, well, we don't need to get technical, a number, any number. So start with A, which is 3729. And let's take number K, suppose is 7. So we can find Ka, which is 7 times 3729. Now, if we are multiplying a matrix with a number, what we do is we multiply all the elements with that number. So we have 3 times 7, 7 times 7, 2 times 7, and 9 times 7. And that gives us 21, 49, 14, 63. And that's it. K can be anything, any number. As long as K is a real number, plus, minus, whatever, we can do this. So that is a scalar multiplication. Just remember, scalar is when we're multiplying a matrix with a number. Doesn't even have to be a whole number. It can be 0.5, can be 0.78. So the first 2 is done. Matrix multiplication is a little bit tricky. Okay, so start with matrix multiplication.